Hi everyone, welcome to Coding Tutorial 6 of Neural Networks and Deep Learning. My name is Everly. Today we're going to teach you how to load a pre-trained object recognition model and then fine-tune that model on a different data set. So our goal is first learn how to load a pre-trained model and then how to inference on it. And with inferencing, we'll teach you how to read images from local directory and from a URL request. And then in the final part, we're going to learn how to fine tune on a pre-trained model. Um, okay, so with the first part, pre-trained model and inferencing, the first step is to load a model, and then second step is to load an image, and finally we will do inferencing. Let's start with part one. All right. Okay, so first of all, uh, let's start with changing the runtime to GPU. Today we're going to be um, training on CNN model, so um, with GPU it'll be a lot faster. Um, all right, so let's start with checking if we have the GPU. Import TensorFlow and test GPU. If we run this cell, it should return a GPU here. And then, okay, let's start with the first step. Um, so here in Keras applications, we can see the list of available pre-trained models in Keras. Um, so here's the list. You can go through this list and check out these different models. And today we're going to use VGG16. So this is how we load the model. And then here are some parameters. We're going to go through those later. So let's first start with importing from Keras. Import VGG16 and then with the model, just let's just use default for now and summary. Oops. So what it does here is that this will help us load a pre-trained VGG16 with all the default settings. And this model is pre-trained on ImageNet here. We go to the arguments. You can find weights. And if you don't want the model to be pre-trained, you can use none. And if you use ImageNet, which is the default, it should be pre-trained on ImageNet. And let's see what this model looks like. So the input size is 224 times 224 size, and with 3 channels, so that's color image. And then there are in total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 convolutional layers, and then plus 3 dense layers, so that's 16 layers in total. Um, and the output is with the size 1000, which is for the ImageNet pre-training. So this is the model we have here. And since we have already loaded, this model is already trained, we can just inference on it. So let's go to step 2 loading an image. So to load an image, I'd like to quickly go through the available options here for your reference in the future using Colab. So you can load from a local directory, which is your Google Drive, and you can also use a URL request. So um, let's start with the first method, local directory. We can do from Google Colab import Drive. So this will help us link to Drive. And then with Drive, mount with this directory should be fixed. So you can just use the exact same code here for your own drive. And then it jumps whether to connect. Yes, connect to my account. Continue. All right, with these steps, I should be able to read from my drive directory. And I created this directory from my drive to CSCI 5922 and then demo. So this is the directory I see in my drive. And here's the image I want to load, German Shepherd.jpg. So with that, um, we already know that the file name is German Shepherd JPEG. So we should do a Google Drive path. And this will be similar to yours. So under my drive directory, you can start from here. And then for my image, my directory is CSCI 5922. And then there's the demo folder. And under that, that's my file. So we can just do file name here. And this is my Google Drive path. And you can do your own path there. And then to read an image, we're using Pillow image here. If you're not familiar with Pillow, you can check out their documentation. Basically, it helps. It's a convenient tool to process image like read and write and resize. So we can call image from pill open. This is help us. This open is to help us load a local, not necessarily local, to load image from a path. So our path would be content and then drive. This should be the same for you too. My drive. This should be the same for everyone. And then after this, you can just insert your own Google Drive path over here. And there. That's how you load an image. And then we can set the mode read and with plot, let's quickly see, use IM show to see if the image is actually loaded. All right, so it read the image. This is the image I have in this directory. And this will be the image that we're inferencing on. But before that, let's quickly go through the second method. If we have an URL here, that leads us to the image. You can also do use URL library request to request the image from a URL. So request URL open, and then input your URL here. use read. And then for the image itself, again, we can use image from pillow, open. And then here we just need to do a quick transfer for the request and put it in here with bytes IO. And with that, the image should be loaded. Image show. Let's see if the image is loaded. Alright, so we read the same image from the URL request. So going forward to read and write image or other data, you can try these two different approaches. All right, and now that we have the image ready, let's move on to the third part, which is inferencing. So for inferencing, um, let's go to VGG16 again. There's a note over here that says Keras application expects a special kind of input preprocessing. So for VGG16, we're going to have to call this preprocess input before we input the image. So there's a couple steps here. First, we do resize, and then change the data type, reshape it, and then finally we do preprocess input. Okay, so we know that the input, we check the model, we know that the input size is 224 by 224. So let's do image. This is the image we just loaded from the URL. Resize it, 224 by 224. Okay, and then next step, convert the image pixels to a NumPy array. So we can import from Keras, preprocessing image, and then just from, this is to convert the pillow image into ND array. So the image will be processed by image to array, and then image input. Okay, so after these two steps, we should have an ND array as the image with 224 by 224 by 3, which is the which are the three different color channels, and reshape the data. So to reshape it, we need to do okay. So usually we input the image. It's either training or testing. It's the same. We input the images in the batch. So it can be several images stacked together. If you can recall from our last tutorial. And here, since we're only inferencing one image, we have to reshape it into the first dimension will be the number of images. So let's do image reshape. And then the first dimension is 1 because there's only one image that we want to inference. And then all the rest should be the same. The second dimension and the third dimension. Okay. And this is the input shape. We're almost there. Finally, we just need to import the preprocessed input. So from Keras, VGG16, import preprocess input, and then with the image input, again, process it, and there. We should have the input data ready now, and what's left to do now is to predict. And here's another prediction processing function. Let's do prediction first. Um, the VGG model we read and predict. Use the image as input. So let's first print the type of prediction to see how it looks like. Okay, so it's an array, and let's do the shape. The shape is 1 by 1000. So there are 1000 um, different categories originally with the with the model pre-trained on ImageNet. And so this is the raw output. And to process these predictions, which is the final layer output, we need to do decode predictions. And the return is a list of top N categories. And we can use that and we can specify that N when we call this function. And then it will return the class name, class description, and the confidence score of the top N categories. So let's process the output. Import decode predictions, and then we can call it label from the output of decode predictions. So we decode the prediction that output from model predict. And let's just do top one here for simplicity. And then the label should be have one dimension out there. And okay, so print. So let's just quickly print the label here. All right, so the label is a list of top N since we're just doing top one. You can see the prediction is German Shepherd. That's the category, and the confidence score is 99%, which is very high. So the model is doing very well. It's well trained on ImageNet, so it's able to recognize this category. And so that is all for loading and inferencing a pre-trained model. And now let's proceed to fine-tuning. So this model is pre-trained on ImageNet, but we can use that um, CNN model that is well trained on this big data set and then fine-tune it on a different data set so that it fits a different task. So today we're going to do Cipher 10 for an example as fine-tuning. So originally, the model is trained on the 1000 categories on in ImageNet, and now we're going to fine-tune the model on Cipher 10, which contains 10 object categories. So let's first load the dataset. And to load the data set, again, it's going to be X train, Y train, and then X test, Y test. Load data. And then Y train, we should do to categorical. We've done this several times now, so I'm not gonna repeat what we're doing here. Let's just process the input with one hot encoding. And then let's print the shape X string and Y. All right, so this is kind of it's not a very small data set, and for training, it contains 50,000 images. And today we're going to quickly try to train on this data set. So let's cut it a little bit smaller. So for X, let's do um, just the first 5,000, and then Y, the same. Okay, so now we have a little bit smaller data set. Okay, let's move on to loading a model. Again, we're going to use VGG, and here are a couple of steps. First of all, we need to load the model with a different setting. This time we're going to use include top as false. So the final three fully connected layers that we saw in the model summary, we're going to lose these three layers and then create new ones. And the reason we're doing this is because we're going to just take the convolutional layers that are well trained on this big data set. And then for the final three layers, we're going to build new fully connected layers, the dense layers into the model, and then just train these three layers on the new data set, which is the CIFAR10 data set. And again, we're going to use the ImageNet for training. So with that, let's do a base model, BGG. We already imported 16, and with the weights is ImageNet. And include top. No, we don't want to include the top. And for CIFAR10 dataset, the image size is 32 by 32. So we can do the input shape. It's no longer 224 and color image. All right, so now we have this base model without the top three layers. And then the next step is to freeze the weights of the pre-trained layers. So what we just loaded here, when we're training on CIFAR10, we don't want the model to backpropagate and then update the weights here. So how we do that is for each layer. For example, if I have a dense layer that's called layer, we can do trainable is false. So we can assign the layers in any model to not be trainable. So how we do that is because we have several layers in base model, so we can do a for loop layer in this model layers, and then we can just do for each layer assign trainable equals false. And there we have freeze all the layers in base model, and all the parameters are not trainable now. For the next step, we're going to create a new model by adding the our dense layers, the three dense layers for training. So we can just assign X. The first step after the VGG convolutional layers is to flatten, and then base model output. Okay, so now we have adopted the layers from base model and then add a flattened layer. So we need to import. Okay. With that, we have the first layer. We can always go back and check the models. So we have until this layer, and the first thing we do is the flattening, and then we're going to do three dense layers over here, and we can see the original defined size. We can just copy that. Is 4096, 4096, and for the ImageNet training, they used 1,000 output, and for Cypher 10, we're just going to do 10 categories. So let's go back to our model. Um, dense, okay, import dense, and then 4096, assign an activation function, and then adopt from X, and another one, and then output will be dense 10 this time for Cypher 10. And for the output layer, we have to use softmax, and again adopt X. So until here, we have the model built, the layers built, and the final step is to create a new model with the base layer and these layers that we defined for output. So let's call this a fine-tune model, and we need to use import from Keras models import model. So this will help us build a model, and the input will be um, the base model, and then outputs will be output layer. That's defined here. So with that, we can run the summary. Let's try running this cell. All right, so we have built this model from here to until the polling, max polling after the final convolutional. These are the parameters that are already trained, and we froze all these parameters, and then we flatten the um, we flatten the convolutional output, and then we do three dense layers here, and the output is with the size 10. So this is the model we're going to train on. The final step is just to do compile. Optimizer, use Atom default, and loss, use cross entropy. And metrics, accuracy. All right. So now we have the model ready. Let's train the model with 5 epochs. The history, and then for this model fit on X, Y, and epochs is 5. Validation data is test X and Y. All right, let's train this model. Um, okay, so while it's training, we can compare a little bit of training a model from scratch. So what we did there earlier with adopting the weights and then with the input shape and also not including the top, these are the steps to load uh, a pre-trained model with the um, with that is pre-trained on a large data set, and we can still just randomize the all the weights when we adopt the VGG16 structure. We can have all the parameters random initialization instead of having pre-trained. But with that, we're going to quickly show you the difference there. With that, the model will be trained much slower and the performance might be um, uh, not as good as the pre-trained model. So, okay, so now we have this model trained and we can see that after 5 epochs, the accuracy had reached had reached 55%, and this is the loss, training loss. And with the validation accuracy, it's around 49. So because we already with the Cypher's 10 dataset, we didn't adopt a lot. We just used around 1/10 of the dataset for training because we need to speed up the process. But you can try like training on a larger data set, like the whole Cypher 10 or other data sets to see how it goes. And now we're going to compare um, the if we don't adopt the weights. So let's just copy everything over. Okay, so for the first step, we just don't adopt the weights, and then uh, with other settings the same. And then this time, because we didn't adopt the weights, we're not going to freeze these weights. And for these steps, they should be the same. And for the model, it's the same. And then just compile is the same. Now we just need to train the model, or we can rename this model random. The history is the model fit, the same train Y train and epochs 5 validation X test Y test. All right, now the model is training, and with this model, we adopt the structure. The model structure is exactly the same as this one that we built, but all these parameters are not trained yet. So it's initialized with random. And then now we're training on the same set of data. We can see, compare a little bit of um, the accuracy here. After the first epoch, the accuracy is around 10%, and it seems like the model is not training very fast so far. Um, because we just run 5 epochs, so it's hard to see the trend, but you're welcome to run more epochs with a larger set of data to see the overall trend of the training. You can see this difference between if you fine tune the pre-trained model on the same data, or if you initialize the weights with random and then training a model from scratch, there's a huge difference there. And that's all for today's tutorial. Quick review here. We learned how to load a pre-trained model, and today we learned how to run an object recognition model, which is a VGG60 model. And then we load, we inference on, we inference an image on this model. And for fine tuning, we learned how to build a model with the pre-trained parameters, and we froze the pre-trained parameters and just trained the final fully connected layers. And and we also changed the data set because this time we're training on Cipher10 and the model is pre-trained on ImageNet. And finally, I demonstrated how to compare um, the training from scratch versus fine tuning on a pre-trained model. So that's all for today's tutorial, and you're welcome to stop by my office hours or leave your questions on Piazza. See you next time.